to hear about how we can do application delivery potentially in a different way. Just quick raise of hands here. Who's in the business of trying to improve the performance, security, and reliability of websites or web applications? All right, you've arrived at the right place. I can even recognize some people that flew over from San Francisco yesterday on the flight with me. So I think we're all in good company here. Who knows about what Incapsula does? Okay, so a good opportunity to educate some of those that don't. This is really what we do. We help companies solve some of their top operational challenges of security, performance, and availability. And the way we do it is through cloud-based delivery. Very much in a nutshell, Incapsula is a cloud-based service that protects, accelerates websites. We're built on a global content delivery network, and we provide website security, DDoS protection, CDN and application optimization, and load balancing and failover. It's all done from the cloud without having to install any type of software or hardware on your hosts. So when we talk about application delivery, I looked up on Wikipedia what's really the broad term or the definition of application delivery, and it's actually pretty accurate. Once upon a time, ADCs or application delivery controllers were that box that you installed or you bought from a certain vendor that helped you do a whole bunch of things around compression and caching and connection optimization. At the end of the day, all of this boils down to three major things: security, performance, and availability. And once upon a time, the way you would build your application delivery stack is something that would, at the end of the day, mean racking up a whole bunch of servers or appliances in a data center, in a rack. If you had a very complex environment, you would start looking like this young fellow here that's overwhelmed with the cables. And you would have to do this in every single data center of yours because that was the way of doing things. But now, as more and more applications are moving to the cloud, us as those that are responsible for application delivery are finding ourselves having to deal with multiple cloud environments. So you could have some apps running at Rackspace, some apps running on AWS, some apps running on Azure, and you've got still some of your legacy apps that are running in your multiple data centers. How do you go about and create a unified application delivery strategy essentially across those stacks or those environments in a way that is going to help you do things consistently, that's going to be future-proof, so you're not going to have to migrate and change things all the time as you move applications between these different hosting environments? There's two ways. One is you can go build a stack like this in each of the different hosting environments. So you've got one built in your physical environment already. You can now say, okay, I'm going to go and build the same virtual rack, essentially, in each of these different cloud environments. Guess what? It's not so easy, because the products that you've been using in your locations, in your co-locations today, some of them have virtual appliances that can run in these environments, some of them don't. Some of them act a little bit or behave a little bit differently in the different environments. So unless you want to have a slightly different or maybe very different application delivery stack in each of your hosting environments, you need to look for a different type of solution. And the second option, which is obviously something that we are touting, is using an application delivery service. So leveraging all these different components that you would once upon a time build or install, manage, maintain in your data centers, using them as a service. So the advantages here are twofold, essentially. There's the generic advantages of running things as a service from the cloud, which are the typical aspects of the cloud. You've got elasticity, scalability, redundancy, and cost. Typically pay-as-you-go type of models. You don't pay for what you don't use, or you pay as you grow. This is what the cloud gives you in general. And I'm sure you guys know about this, and I'm not here to talk about that, because that's a given when you use a service, that it can scale upon demand. It's got infinite capacity. It's built as a service, so it's got redundancy in it. Most clouds should be built that way. I'm saying should because not all are, but they should be. But there are inherent advantages in each of the application or the subjects that you're trying to improve from the security side, the performance side, and the availability side, if they are run and executed via a cloud service. So when it comes to website security or web application security, I'm sure most of you know some of these statistics. 96% of all applications have vulnerabilities. Not only that, what we've seen is that 61% of web traffic today is actually not real humans coming to your website. It's all automated stuff. Half of those bots, or that traffic is, you could call it malicious. It's not good traffic. It's not the Google bots or the Bing bots or the pingdoms or the keynotes that are coming out to your website and doing things that you've actually asked them to do and you find benefit in. It's all those services that are either trying to scan your website and see if they are vulnerable, and if they are, they will alert the hacker on call to come and hack you, or they may just do it as in a script. It could be your competition that's hired a service to tell you every time your website changes. And while they are doing a legitimate scraping of your content, do you really want them, and can you really keep them out? They could be doing reverse engineering of your shopping cart. Are they looking at what your prices are, or what you're selling products at, and offering them at 2 cents lower than that, so they come up higher in a comparative search engine type of scan. All of these things are happening, and there's good incentive in trying to solve them. Some of the advantages of dealing with security for web applications in the cloud are using crowdsourcing technology. So a service that's seeing traffic for hundreds of thousands of websites simultaneously, instead of you installing something in your data center that has a siloed view essentially of your traffic, can really tell you, has this IP address been used in a different attack on a different customer? Has this type of attack vector been used elsewhere? And these are some of the advantages of cloud security. If you think of a parallel, once upon a time, the way we did email spam was we had a device that sat in our secure web gateway, and it looked at signatures in the emails. Does anyone do that anymore? No. It's all going through the cloud. The reason why it's going through the cloud is because it's all reputation based. So they're not looking at what's in the emails anymore. They're looking at who the email is coming from. Have we seen them in the past? Is this email going to other recipients as well? Those are the type of things that are the leading indicators to what's spam and what's not. And that's the usage of this global view or this crowdsourcing technology that you can use when you're using a cloud service, because you have so many tenants essentially on the network or that are using the service that you can enjoy this intelligence or economies of scale. The other thing of when you're doing website as a service through a service provider, the service provider does everything for you. You don't have to be a web application security specialist. You don't have to know what the new vulnerabilities for WordPress are if you're running a couple of WordPress apps, or if you're running some Drupal apps. I don't know if anyone's running Drupal apps, but during the last Black Hat conference, someone announced, showed a CVE that could take on Drupal and WordPress applications literally with a single server. When those type of things happen, most IT administrators, have to, the whole time to patch becomes an issue. How fast can you patch? Is there even a patch available? Because often the bad guys or the good guys, the ethical hackers, will obviously contact the Drupal guys and the WordPress guys and give them a heads up so that when they disclose, there's a patch in place that anyone can download. But that doesn't happen when the bad guys find a vulnerability and publish a kit on how to DDoS websites. And even when the good guys do that, the time to patch is forever. There are millions and millions of open source stacks and even proprietary codes that have never been patched and will probably never get patched. When you use a service, whoever's running the service essentially applies what's known as virtual patching. So in our instance, we have a security team that what they'll do is as soon as a CVE is published, they'll come up with an antidote, which is essentially a rule trying to identify someone trying to exploit that specific vulnerability. And once they put that rule in place, essentially the hundreds of thousands of websites that are using a service like this are essentially immune to that vulnerability, which really helps with dealing with and responding to zero-day attacks. Do you have a question? No, sorry. The other thing that makes a lot more sense to deal with from the cloud is dealing with DDoS, distributed denial of service attacks. This is some research that we published beginning of the second quarter of this year. There's a 240% increase in the number of bots or zombies that were essentially used in DDoS attacks over the last year.
I'm sorry, I thought you were going to get to this before we transition. How do you deal with the fact that people are spoofing their IP addresses? If you crowdsource a particular IP address, you might have legitimate traffic, but the person might spoof the IP or they actually might compromise the server.
Okay, so that's a good question. I can piggyback on the DDoS discussion to talk about that. Average DDoS attacks are 40% larger than they were last year. So we're seeing 150, 200 gig DDoS attacks today. If we would have spoken to most people in this room a year ago about 150 and 200 gig DDoS attacks, you would have said, here's a fear-mongering security vendor that's entered the room and is preaching or is talking about the Armageddon of the internet. We're seeing this today. Unfortunately, companies have to deal with it. In order to deal effectively with DDoS, you have to have a bunch of things in place. You have to make sure that from a volumetric perspective, you can deal with it. And that's where the cloud really gives you a lot of advantage, because no single company wants to have to build a 200 gig resilience footprint, essentially. Why not leverage the economies of scale and have a service provider do it for you, and then you use it when you need to use it and pay a fraction of the price, essentially, that it would take you to build the service. The other areas of that are required from, or the other advantages of delivering this from the cloud is the crowdsourcing. This is where we talk about spoofed IPs or not spoofed IPs. And you can really, when it comes to DDoS, split the world into two. There are the network-based DDoS attacks. Most of them are spoofed IP addresses. Okay, you don't need to create a full TCP handshake with the attacker, and that's why DDoS attacks are the IP addresses are spoofed today. The technologies that are being used are amplification and diversification. So I'm sure you guys have heard about the NTP reflections and DNS reflections. These are essentially mega servers that someone's taken over, someone's hijacked my account on Amazon, or I've got a bunch of servers in a hosting provider with a hosting provider. I have a 1 gig pipe. Okay, I have some good servers behind that pipe. A 1 gig DDoS attack today is pretty tiny. But what I can do with that is if I use these amplification and distribution techniques, I don't want to call them technologies, but I want to give them that amount of credibility. But if you use these techniques, you can essentially amplify the amount of traffic that you can generate at a target, and you can also diversify it. So it's coming from essentially multiple IP addresses of all these NTP resolvers or DNS resolvers, because it's bouncing off them. The way the attack essentially is done is I send a request to an amplifier. It could be an open DNS resolver asking them for something. But I spoof my address as the target's IP address. That responder essentially responds back with a bigger payload than my request. And therefore, you're essentially creating amplification, but they're not responding to me. They're responding to my target, who obviously didn't make that request. And that's how they're getting hit with X30 to X50 of the amount of traffic. So if I could generate 1 gig of traffic with that server that I've taken over, I can generate a 30 to 50 gig DDoS attack through amplification and diversification. The way cloud helps you in these scenarios is these types of attacks are leveraging essentially public infrastructure. If you can map them, so if you had a theoretical map of all the open DNS resolvers that are out there and vulnerable in the internet, and you saw requests coming from them, high volume requests coming from them, you would know that it's a DDoS attack. Okay? If you have to maintain all those lists as individual companies or organizations, it's a nightmare. Because A, you see a very small subset of them, and you also have to have someone on full-time job to maintaining those lists. As a service provider, we do this because we essentially are leveraging the economies of scale. Same when it comes to botnets. Botnets are actually, they're typically used in layer 7 types of attacks. They do create a full TCP handshake, and they're typically used for layer 7 attacks. So they will try and overwhelm not your networking resources, but they'll try and overwhelm your application resources. In that case as well, you have to have if you could have a theoretic map of all those botnets, because you've seen them in other types of attacks against other tenants on the network, you can then use that information, leverage that essentially cumulative learning curve across the entire customer population in order to make more or better effective decisions. So I've spoken about most of these things. Obviously, when it comes to volume, you have to have a cloud service that can deal with this. So again, as I said, building a infrastructure that can deal with 200 gig DDoS attacks today is practically impossible from a single tenant perspective. And having this as a service with the right people or SWAT teams, not having your in-house guys having to deal with DDoS attacks. Most internal SWAT teams today, if they do undergo a DDoS attack, they are typically the first thing they do is they call either a service provider or they call a specialist, because it's just becoming such a highly specialized area today. They're doing this on your own, just doesn't make sense. The third area of application delivery is probably the most established and is performance. These are some stats from some of the analyst groups and other research that's been done on what the impact on latency can do essentially to the effectiveness of your web delivery or your web applications. And the way the industries solve this essentially is through using content delivery technology. The ideas behind content delivery is bringing the content closer to your end users through caching it closer to the end users on multiple, through a global network. And the other thing is using techniques like reducing its footprint. So caching, compressing it, minifying it, improving TCP connections to the end user or to the origin server. These are all techniques that essentially have been done in the past. And our view on a CDN today is actually it's a backbone of application delivery. So without CDNing type of capabilities, doing all the other things that I spoke about are essentially non-starters. No one's going to put their application delivery or no one's going to try and source security and availability and DDoS mitigation if it's going to slow down their websites. So if you haven't got CDN capabilities built into the service providers or the cloud providers that you're using to route your traffic through, it's really a non-starter. The marketing guys are going to kill you for slowing down their websites. It must be a given. So it's part of, it's like having power running through an appliance. If you haven't got it, it ain't going to work. There are obviously different things you can do. Different CDN providers have different, specialties and secret sources. But CDN, in terms of application delivery, CDN, in our opinion, is the new chassis of application delivery from the cloud. The fourth area is how do you improve availability through a cloud-based service? And there are really three things you can do in order to leverage the cloud more effectively. The first thing you can do is essentially intra-data center load balancing. So you can have, if all the traffic's running through a certain service, instead of having a local load balancer, you can actually do load balancing from the cloud, as long as the IP addresses are publicly routable, and there are techniques to even do it if not all the IP addresses of your servers are publicly routable. You can do it in a consistent way. So if you're on Amazon, you don't have to use ELB, because then if your other applications are on Rackspace, you don't have ELB. Same on Azure. You can use a single controller essentially from the cloud as a service to do it in a consistent way. You can also do data center failover. So yes, you are in multiple environments. How do you have this one single traffic cop essentially that can make intelligent decisions on which of your data centers are struggling, which of the servers are struggling, and then make decisions on how to route traffic through to alternative origins. And the third is global server load balancing. So this is more, can I optimize my content delivery or my applications regionally? So I have a New York data center, and I have a London data center, and I have a Hong Kong data center. And what I want to do is, in addition to some of the failover that I've orchestrated among them and the intra-data center that I'm using to load balance within them, I want to say all my traffic from the US goes to New York, all my traffic from Europe goes to London, and all my traffic from Asia goes to Hong Kong. How can I do that? You can do this all from an application delivery cloud service that's receiving all this traffic and doing this in a single consistent way across any type of application. The advantages are, of course, using some of the existing technologies that you would do to do intra-data center load balancing, different type of load balancing algorithms like least pending requests and open connections, or even source IP hashes. Again, the advantage is you've got one platform that you can roll out regardless of where you're hosting. You may have multiple organizations that are building data centers, the whole shadow IT phenomena of different groups in different organizations putting up their own websites through third-party providers. You can actually take this and put this on top of what they've built. So you're not slowing them down. You're actually helping them to speed up their delivery, secure their delivery. If they get hacked, if this is a small, non-data sensitive application that the marketing department in an organization put up and it gets hacked, guess what? Your brand goes in the New York Times, regardless of the fact that it was a esoteric application that no one actually looked at or audited from an IT security perspective. What I wanted to go through in some of the remaining time is some examples of how some of our customers are using this, to give you some examples of use cases. So in this first case here, we're talking about the world's largest social trading and investment network. It's a company called eToro. They essentially leverage peer-to-peer conversations and shadowing and following to see what other people are investing, how they're investing, and drive an online trading platform. They've got a very complex environment in the sense that they've got multiple websites. They have different marketing websites. They've got different landing pages. They've got multiple affiliates in different geographies that are working on their behalf. They have forums and blogs where their traders talk to each other and can essentially share information. They also have a real-time trading platform. So the response has to be, we're talking about seconds, quoting different commodities or stocks. And they also have a multiple, what I've called here, end-user clients. They've got customers that are using a web interface through HTTP. They've got customers that are using a custom app. They're high rollers and they're high-end customers. They've actually got trading apps that they're using, similar to what the guys, a bunch of blocks down the road here are using on their big screens to do trading. So it's a very complex environment. They also have multiple hosting environments. They have their core is in a dedicated, co-located type of environment. They also leverage a cloud, and they are moving more and more apps into the cloud, and some of their satellite activities are already built in the cloud. Their requirements were obviously around speed, application acceleration, and caching, and I'd say primarily security. So as a high volume trading platform, they were subjected to multiple DDoS attacks. And what they really have done is been able to use, in our case, our application delivery service to essentially blanket all these different infrastructures, done in a uniform way through a single vendor environment, regardless of where it's being hosted or what the application is. In this next example, we're talking about a worldwide VoIP provider. So once again, they have very complex systems. They have, again, their marketing websites through which they acquire customers. They have the SaaS platform itself. So they're a SaaS provider. That's where you're in the cloud PBX. It's where you go in and you create your extensions and you go and create your rules, and each of your end users can go in and manage their voicemail. They have their VoIP infrastructure. So they have lots of servers that handle their VoIP infrastructure, and they even have they have connections into a PSTN network. Once again, here their hosting environment's pretty complex. They have co-located and cloud infrastructure for which they need to accommodate their solutions. Here again, most of their requirements were around application security and DDoS, so they need to make sure that the VoIP is up and running. Telephony is a critical infrastructure for their customers. It can't go down. But they also have availability concerns. So they have multiple data centers, and they can use this type of service to fail over from data center to data center in case bad stuff happens. Third example here is a leading money transfer provider. People come to their website and decide they want to transfer money from one location to another or from one entity to another. Again, here they've got their marketing websites, they've got their payment platform. They're also located in multiple data centers and in the cloud. Their requirements are, first and foremost, security. They're dealing with money. They need to be PCI compliant. They need to have a web application firewall in place. They also have a pretty bad challenge with fraud, and that's where leveraging some of this crowdsourced technology of telling them which IPs have been seen in bad transactions or bad activities elsewhere gives them some good insight on what could potentially be a fraudulent transaction and what's not. DDoS, both application and volumetric as well. And of course, data center failover. So these are a couple of examples here of how some of our customers are using this in multiple environments, just to give you an illustration of how this technology can be used. There's also those that didn't use these type of approaches, such as the Codebases of the world or Evernote recently that were DDoSed. So that's just some fruit for thought on those that have decided to do things differently, sometimes on their own or sometimes that are not doing anything at all. The end result wasn't the best. So I have 10 more minutes, and I'm happy to take any questions that anyone has.
Speak of the need for CDN, because obviously you want to route the entire infrastructure through a service like this. If it's going to add hundreds of milliseconds latency, what about highly dynamic content that's hard to CDNify?
I like that term. I may start using it. So that's a very good question. And I think that, there's lots of CDN providers out there, and lots of them are maybe in this room, definitely on the, on the show floor. Each CDN does different components of the application, of the content delivery. We have specifically focused on the application acceleration, and that means we've focused essentially on three main things. One is having a global network and the ability to bring the content closer to the end users. Most dynamic applications, the actual dynamic payload is about 10%. Although it could be an online banking application. Okay, what's more dynamic than that, and what's more sensitive than that? I don't want to show you someone else's balance page or serve you the wrong content. However, you can take a dynamic application and run it through a CDN. Because your JavaScript, your CSS files, some of your smaller images are all the same across all your customers, and they can be identified. What we've done is invested in a lot of technology in being able to identify what's cacheable and what's not, either by the fact that you tell me what's cacheable and what's not, or we've implemented lots of algorithms that will essentially detect what's cacheable and what's not, what's changing. So most applications are rendered from a database today. If you don't tell a caching server, and CDN is a caching server, it may be globally distributed, and it's got a lot of smarts around it. If you don't tell the server what to cache and what not, it's not going to know. We've invested a lot of technology in being able to identify what's cacheable and what's not, and that's through learning algorithms. We can, we look at resources, at requests and resources that are coming back dynamically. And when I say identify what's cacheable and what's not, I'm talking about MD5 hash, binary compatible, responses. When we see something from multiple IPs, from across multiple users, multiple accounts, that is constantly returning the same type of resource on the same type of request, we know that it's cacheable. We've built in our user interface capabilities for our customers to be able to tell us how to cache and how aggressive to cache and how and what not to cache. We've got a very robust API which you can tell us to purge information. We'll typically purge something within 15 to 30 seconds across our entire network. So we've invested a lot in trying to not just optimize the connection between the CDN and the origin, which is important as well, because if you do have to go and fetch content, because it's dynamic and it's coming from a database or from an application, you do have to traverse or transfer the data. Optimize that from a network perspective, but also if you can do some learning and you have some smarts on knowing what to fetch and what not to fetch, you can save a lot of time and really improve dynamic application delivery. So that's kind of my 2 cents on that.
So we've been bitten in the past by other things, cloud services failing, right? AWS goes down and the East Coast and stuff happens, right? So like, what do you say to somebody who says that, like, hey, you respond to the question, like we're giving you, like you're protecting us from DDoS, from all this stuff. You're now our single point of failure, right? So like, are we supposed to like buy your stuff and also create a network infrastructure behind that as well?
So that's a good question. I think that, at least from an Incapsula perspective, when we say that we are a single cloud service, it doesn't mean that we've got a single server in a data center. Okay, so our service is built today on 21 data centers. By the end of the year, we'll have 30 data centers. Each data center is a 20 to 80 gig data center in terms of capacity. If one of them gets knocked off, within 5 seconds, traffic routes to alternative data centers. So we've built, I believe, the utmost resiliency into our network. I wouldn't expect anyone to build that type of resiliency on their own. It would cost them millions of dollars. I can tell you, we spent millions of dollars on building this. The challenge is that you're with a service like us, but we're this front end for many customers. These are the same type of problems that you as an end customer would solve. When you go under DDoS attack, okay, we have to deal with not just staying up, not just a transit provider of ours failing, and that's why we have multiple transit providers in every single data center. But if that single data center goes under a 50 or 60 gig DDoS attack, we have to be able to deal with it. That's the type of methodologies and technologies that we've built into our service to be able to provide that resistancy. We provide a 5.9 SLA to our customers, and we stand by it. I don't expect any single customer of ours, unless you're talking about the Googles and the Facebooks that have done everything on their own. I mean, if you walk into a Google or a Facebook data center, they've got data centers that are waiting to get DDoSed. They're standing there, they've racked up, they've bought tens or hundreds of millions of dollars worth of equipment because they do things their own. They can afford the economies of scale of doing this on their own, and that's they're not a customer of ours for DDoS. We do have very large customers that use us for DDoS because they are unable to create that type of scale in order to to deal with it. So yes, we are essentially. You could look at us as a single point of failure. However, I think we've done a good job on creating a lot of redundancy and failover capabilities within the service that it's a less of a point of failover de facto. Any other questions?
How do you answer the question? I'm going to try to put you on the spot here, but how do you answer the question that you're trying to be too many things at the same time, or that question?
So it's a good question, and I have 5 minutes, so I'll try and answer it within 5 minutes. Most of what we do was really an evolution of our service. When we founded the company 5 years ago, we founded the company to go build a web application security as a service. Okay, we spun out of the leading player in the industry, a company called Imperva, to go build a cloud-based web application firewall. And it was supposed to be in the cloud, zero hassles in terms of adoption, DNS redirect. A bunch of engineers got in a room, thought of what we needed to do. And we, as we started talking to potential customers, even in our initial planning, we were initially said, well, we're not going to use your service because you're going to slow us down. There's no way we can route traffic through an additional reverse proxy. Non-starter, go back to the drawing board. So we said, okay, we've got to build a CDN because if we don't have a CDN, it's a non-starter for any of these services. So we built a CDN and it was really a defensive mechanism. Okay, so how can we speed up the mechanism, the application? So when I walked into a customer and I wouldn't have to be asked, well, how much are you going to slow my applications down? Because if I have a CDN on my marketing material and we've got a really good CDN, it takes that question completely off the table. So it was really a defensive mechanism to start our business. As we onboarded thousands of customers onto the network, we started getting DDoSed. Okay, so the only way for us to keep our service alive, because when someone hits a customer of ours on our network, everything shakes. So everyone else starts shaking. And if you haven't got resiliency built into your network, you're not going to have a business. So we had to build a bloody big boat in order to sustain these DDoS attacks and develop techniques in order to mitigate them. That was to protect our own network. Okay, so we built a really good DDoS detection and mitigation service to protect our own business. Now we've got more and more customers that are coming to us because we've got such a good DDoS mitigation capability. So that's some of the evolution. When it comes to load balancing, we had customers coming to us telling us, hey guys, I'm routing all my traffic through you. You're protecting me. You're front-ending me. I'm moving into a different environment. I don't have my big IP anymore. I can't use it. Can you guys help me? So that's where we've helped them with some of the load balancing and failover. So yes, we do sometimes run into that, so you guys are a jack of all trades. I think as soon as people understand that that's how things evolve, they can understand the logic behind it or why we had to do it. I think more and more people are realizing that most of these components should be delivered together because they are essentially, having a CDN with no security, then, okay, what do? You go and get another CDN or another cloud, service provider. Should come, there should be all these functionalities built onto the same chassis. If you look at some other companies, F5 did that. F5's got, the big IP, and they've got a web application firewall module, and they've got an SSS offloader module, and they've got some of these other things that you can do. We've taken the same thing, we've built it in the cloud. So that's the 4-minute version of it.
Maybe just one thing, as far as SSL, do you provide any sort of layer 7 load balancing, like looking at packets, are you decrypting anything in SSL?
Everything we do is layer 7. So we decrypt your SSL.
So do you have customers that are concerned about distributing their keys and service all over the place?
We do. We're a service. Yes, we're a PCI service provider level 1. We have lots of e-commerce, banks, financial services, government agencies that are routing their traffic through us. Those that are, there are countries, by the way, where, like the central bank will say your keys cannot reside in the cloud. They have to be on premise. It's a challenge. But those are the laggers essentially from an adoption perspective. If you think of where some of these large organizations that once upon a time you spoke to them about the cloud and they said, we're never going to be in the cloud. They're spending millions of dollars a month now on Amazon and at Rackspace and at Terramark. I think that's part of the we provide them with assurance. We go through audits that the keys are in good hands. We manage the keys in a professional way. It's part of the cons of doing things in the cloud. Right, I'm getting the. Okay, I do have what's called office hours, that start in 5 minutes. So if anyone wants to ask me any more questions, I'm available.